Right. So we've been kind of going through a lot of the different formats for math counts competitions. Uh, so we namely saw a sprint round. We saw the configuration of a target round. There is also a team round where four people from each team will participate, but that's a little hard to replicate here because we need to have a faculty member in every single breakout room for doing that. But the other kind of math counts round is going to be a countdown round, and that's what we're going to try to simulate a little bit today. So just note here, because I know like a lot of the school districts are off for Thanksgiving break, so we won't have meetings the next two Saturdays, but then we'll have a meeting for 6th, and then we'll start looking at some games. All right, so what is this countdown? So most math counts competitions do have this, but not all. Some states don't use these things at all. Some do. Sometimes they have them at chapter. Sometimes they only have them at state. The rules kind of vary a little bit from state to state as well. So the basically what you want to think about the math counts countdown round is it's kind of like a game show. You got two people competing head to head with buzzers, right, to try to answer questions as fast as possible. So basically, in most states, sometimes it's 10, sometimes it's 12. It can depend a little bit, but usually there's 10. And then so how this would start is the 10th place finisher on the written test is going to go head to head against the 9th place finisher. Whoever wins that is then going to take on the 8th place finisher. Whoever wins that is then going to take on the 7th place finisher and all the way down the line. And so with each one of these rounds, what they're going to do is they're going to put some questions on the board. There's going to be a person reading the questions, but probably it's a better strategy to look and read the question because you're going to read faster than the person who's going to be reading the questions out loud. And there's a time limit of 45 seconds. Now, so you have 45 seconds to answer the question, but if the other person buzzes in before you and gives the correct answer, you're done. So whoever answers correctly first, but if you buzz in, that's your chance. You don't get two chances to answer things. And so for the first few rounds, it's a best out of 3 situation. And so that might mean you win 1-0 or 2-0, or, because sometimes no one gets a question right. But if there's tiebreakers, they keep going until someone wins the tiebreaker. So if it's 1-1, and then there's one question you didn't do, they might keep going until someone gets a question correct. So the winners kind of keep moving down the line until you get to the final 4. At least this is how it works in Kansas. There, the rules change slightly that you can't win if there's 3 questions given and only one person gets a question right and the score's 1-0. That person doesn't win yet. You got to get to 3 correct answers, and they keep going until one person finally hits 3 correct answers for the last 4 spots. And a lot of times the last 4 spots might be a scenario where it qualifies you to go from the chapter competition to the state competition or from the state competition to the national competition. So they just kind of want to make sure that that person does have a fair number of questions correct. Now, again, not every state does this. A lot of states don't do this at all. It can be a very stressful thing. I have kind of mixed feelings, to be totally honest, about the countdown round, but some people really enjoy it. And you cannot use a calculator, but they do provide pencils and paper as you do this. And most rounds have a buzzer set up. So, and this varies from place to place how sophisticated the buzzer setup is. But generally as it goes, again, a question's going to get probably put on a projector. Someone's going to be reading it off, but you have your chance to buzz in. So what I want to do here today is we're just going to look at a particular year's countdown round. Now, I should note here, the questions kind of vary in difficulty, and it's not always consistent that question 5 is harder than question 1. Sometimes there is a little bit of a, raise in the difficulty level as you kind of go through these things, because in large part, questions 40 are probably more likely to be asked to the top competitors in the contest, so whoever got first or second on the written test. But there's a little bit of strategy that you might want to think about here. So one, again, I probably wouldn't wait for the person to finish reading the question to buzz in if I know the answer. I would probably be reading it off the screen as I work on it. But one thing is you have 45 seconds. So this is something that I see a lot is people, okay, so you're going head to head against someone and they get the answer wrong, right? And so you have the rest of the 45 seconds. You don't need to rush. You can double check your work. You do need to buzz in before the end of the 45 seconds, but you have that time because they're kind of out on that particular question if they got it wrong already. So if your competitor gets it wrong, use your time is an important thing. Don't rush, because I know a lot of times in these tests we're in kind of a rush mode. And our mindset's like, boom, I got to get it as fast as possible. But use your time if you're in that scenario. If you're in the scenario and you don't know and there's 1 second left, make an educated guess, just like 4, whatever. It can't hurt anything. You don't get punished for having a wrong answer necessarily. So if you weren't going to answer anything and the time was going to run out, you might as well try something. And then generally speaking, you have 3 seconds after you buzz in to answer. The rules can vary from site to site. I know not everyone here is in Kansas, so you might have different rules if you're from a different state. Generally speaking, if you say the answer before you buzz in, that might disqualify you from the question, or they might not count it and things like this. So you do always want to buzz in before you answer. A lot of times they call on you. So you buzz and they say, Craig, you give us your answer or something like this. And then here's where there's the risky strategy. Some people can do this. I see this backfire quite a bit too at contests where some people buzz in before they actually have their final answer. So they might be working it out on scratch paper. No, I almost have it. I buzz in and I'm going to use my 3 seconds or 2 seconds to finish the problem and then give an answer. Again, this is pretty dangerous. You might not finish in those 3 seconds and then you're out of that particular on that particular problem if you get it wrong. But some people who practice this a lot do this. I mean, I see people sometimes at the national contest, they basically just buzz in. They're like, I will be able to answer this question in 3 seconds. And so if you ever want to see an interesting thing, you can go to YouTube. They have all the national countdown round contests. A lot of times they have either a famous scientist or sometimes a celebrity reading the questions. They have a big production team, lights, all this stuff. They do interviews. It's kind of entertaining, but I imagine it is pretty stressful for the participants. But you'll see that a lot of times the students oftentimes will answer the questions before I am a quarter of the way through reading the question. So it's a pretty interesting event, to say the least. And I should just note, Nationals has a different format. They do this kind of weird tournament format. So if you're ever there, it's going to look a little different than how things would be ran at a chapter or a state, at least in the state of Kansas. Okay, so that's my spiel about just kind of going over how these things work. What I'm going to do is I'm going to give you a bunch of questions, and I am going to have a timer going, and you can answer the question. Someone asked, are Nationals the hardest? The questions at Nationals are harder. Generally speaking, so MathCounts kind of has technically 4 rounds. A lot of the schools around here don't have a local round, which might be just an inter-school contest to determine who is going to go to the chapter event. The chapter event is where you can qualify for state. Chapter is usually harder than the local. State is definitely harder than the chapter, and Nationals is definitely harder than state, in my opinion. Yes. Okay. So everyone got your pencils and paper? Anyone need a moment? And maybe I'll narrate a few of these, but you can probably see. Someone asked how many questions are in the 4 rounds. So the sprint round has 30. The target round has 8. The team round, I believe, has, I'm thinking 10 problems, maybe it's either 10 or 20. And then the countdown round just has as many problems as it takes in order to do everything, so in order to determine wins. Yes, go ahead and ask your question.
So do you have to have a team to be able to still participate in the math counts countdown, or do you have to have a team to do it?
For math counts, so the countdown round is all about the highest individual scores. So if you're competing as a non-school competitor, It is possible. Yeah, I mean, I know, for instance, at state, the person who won state 2 years ago was, I think, was either a non-school competitor or he qualified for state, but his team didn't. So generally in Kansas anyway, so our regions, the top two schools that like, so there is a team calculation that takes all the individual scores plus the team round scores and puts it together. The top two schools from each region qualify for state, and then the top four individuals, which they may already be on those top two teams, but they might not be. But also, if you're anyone here looking to compete as a non-school competitor, one thing that you might consider though is just seeing if there's people at your school who'd like to compete. So, for instance, I know in the Manhattan area, Anthony does have a team, but Eisenhower, there's some people trying to make a team. So it might be possible if you're at some of these schools to try to find some other people, because if you have four people, then because of the way it's scored, if you don't have a full four people, it can kind of hurt your score with the calculation because the individual scores of all four people count. So thing to consider. But yeah, you can qualify for the countdown round or go to state as a non-school competitor. That's totally possible. Alrighty, so let's do a problem. If my pen works. Great timing. So if f of x is equal to x squared minus 3 and g of x is equal to 2x plus 1, what is the value of f of g of 3? Then we'll go through each problem. My pen is locked.
So can I say the answer out loud?
Please don't say the answer because other people will be kind of working. So you can just do things in the chat. So every person who did enter it in the chat did get it correct. Work through this. So, and again, some of us might not have had. I'm very annoyed. My pen is not working. So with this, again, I know some of us haven't seen algebra yet. So what you do is you'd first plug in 3 into this function g of x. So you'd f of 2 times 3 plus 1, which would lead you to try to compute what f of 7 is, which is 7 squared minus 3. Get 49 minus 3. You'd get 46. So yeah, and so everyone I saw in the chat did answer correctly. I sorry I didn't kind of get through marking things down that they were correct. So let's try another one. So this one, about half the answers I saw were correct and half were incorrect. But and this is always one of the tricky things when you try to do things really fast. So what I would do if I was working on this problem is to try to convert everything into powers of 2. So 2 to the power 4 raised to the power 9 is going to be the same thing as 2 to the 36. But downstairs I have this 4, but really 4 is itself going to be a power 2. So this is 2 squared, to the 8th power to the 2nd power. And so if you're doing this calculation, we have 2 to the 36. Downstairs, I have 2 to the power 2 times 8 times 2. So this would be 2 to the 32. So when I simplify this up, I would just have 2 to the 4, and I would get 16. So again, paper is definitely probably going to be necessary with a lot of these problems. Some are going to be possible to do just kind of thinking it through, but a lot of these you will need a little bit of work in order to do this. So, okay. And if anyone has any questions, just let me know. Okay, let's try another one. So seeing a lot of answers that were correct and a few that were really, really close. So when you do this, you got to kind of think about how you could have these numbers add up to 8. So for instance, you could have 1 and 7. You could have 2 and 6, 3 and 5, 4 and 4, 5, 3, 6 and 2, or 7. So, but you can't roll 8 because there's no way to get a 0 on dice. So there's a total of 7 ways you can do this. How many different ways can you roll these two things? Well, there's the 8 ways to roll the first die, 8 ways to roll the second one, and you left with 7. And so I saw some people had 1/8 was a very common response too. And like if one of the dice was 0, so I could see if you're kind of doing this quickly, that is probably a pretty reasonable guess. Okay. If no one has questions, let's try another one. We're just going to try to do as many as we can kind of fit into our class today. But like with these things, I've sent your parents and guardians like links. You can find like just tons and tons and tons of these math counts, exams and AMC exams with solutions online. Someone asked why multiply the denominators. So because there's two of these 8-sided dice, so this is going to be the first dice. This is going to be the second. So there's a total of 64 ways when I'm kind of counting things with the order that they're doing it. Okay. Let's try another one. What is 120% of 45% of 1,200? All right. So when we look at this, yep, I'm seeing a lot of correct answers here. Okay, so let's just kind of see how we can do this. These things would be really fast to do with a calculator, but if you don't have a calculator, it's a little bit trickier. So I would usually convert these things to fractions in simplest form if I can. This first one is 6/5. 45, well, maybe I could do something simpler, but I'm just going to write it initially as 45 over 100 times 1,200. But this is kind of nice because I can kill off the 100 with the 2 zeros that I have here. I could also see that I could remove my 5 and be left with a 9. And I'd have 6 times 9 times 12. And you can maybe multiply this in different ways. If you're trying to do this quickly, 6 times 9 is 54. Times 12. Maybe I break this up as a 10 times 54 is 540. 2 times 54 is 108. And I get 648. So how you do the arithmetic, you might be able to do in a lot of different ways, just to be honest. So this is just kind of how I would do it. And how much you write, like this is a speed thing. So this is not going to be a contest where they're grading your work. So if you can scratch work and kind of keep track of things in your head, you might be able to do things faster, even though whatever you have in your paper looks like absolute gibberish. That's okay. They don't judge if your paper is really weird, but you do need to kind of write things down so you can keep track of stuff. All righty. Let's try another one. But if anyone, the zeros are canceled out. Someone said yes. Oh, there's a question. Yes. Go ahead.
So do they judge you on your work in the other tests?
Not on these. So there's a lot of different types of competition. So MathCounts contests, they're just final answer, and you're going to write a number next to a blank, and they're just going to grade the number. And usually with MathCounts, they give you a very specific format, like round to the nearest 10th place, or write it as a fraction or simplest radical form or something. The AMC 8 is all multiple choice. So here, so the countdown run is the one where you're not going to have a written final answer. You're going to buzz in and be like 648 after they call on you. So, it can be fun, can be stressful. Some people even opt out of the countdown round. I've seen that. Like, so actually, there was one year I think that the highest scoring person on the written contest national math counts decided not to participate in the countdown round. So some people like I think like try to have fun with it. Don't get too stressed out about it is like the best advice that I have. Okay, so let's try another one. Oh, but I will say there are a lot of things like, so if you do the Manhattan Math Olympiad, so I've sent your parents and guardians information about some other contests there. It's a 4-problem thing and they're totally grading your work. So, so there are some contests where they do grade work. Let's try another one. Getting a lot of correct answers in the chat and some incorrect ones too. That's okay. So with this one here, we know that the digits themselves have to be prime. So what are the one-digit prime numbers? Our options are 2, 3, 5, and 7. So we want to make the biggest number that we could with these particular numbers. But when we think about it, okay, so I want the tens place to be as large as possible and I'd win the game. So I probably am going to start out thinking about numbers in the 70s, and then I kind of go through, well, okay, so I'm looking for the greatest 2-digit prime number whose digits are both prime. Well, so 77, I check. Oh, wait, that's 7, 10, 11. 75 is divisible by 5. 73, does that work? And then you could kind of maybe quickly figure out that that doesn't have any prime factors, or maybe you have your prime numbers up to 100 memorized. So 73 is going to be the correct answer. All right. Try another. Right. So I'm seeing the number of correct answers. The one thing that's tricky, and I apologize for this, like if you're putting answers in the chat, I'm trying to mark the correct ones and things, although they're coming in so fast that it's actually toggling things and kind of making it hard for me to put the emoji stuff in. So with this, how could we do this? Well, this is where you could use your difference of squares formula. This is 212 plus 211 times 212 minus 211. Now, this first one, we can add it up. It's not terrible. We get 423. But when I multiply this is super duper nice. This is 1, and I'm just left with the answer 423. So a lot of times with these types of problems, you are kind of like there usually is a shortcut. Usually they're not expecting you to take a power of 212 or 211. So a lot of times if you see enough of these, you kind of have a guess of what you might want to try to do. And again, they will be reading it off. A stalk of corn is 32 inches tall. It grows by 25% of its height each month for the next 3 months. What is the height of the stalk in inches at the end of the 3-month period? Express your answer as a decimal to the nearest 10. Yeah. So in oftentimes in the contest, I forget how it's done in Kansas. If it's 5 seconds or 10 seconds, they usually give you a running. Okay. So how could we do this? So we have a 32-inch stalk of corn here, and it grows by 25%. So that means I'm going to be 25% bigger, or effectively I want to multiply by 125% every single time. Multiplying by 125% is the same thing as multiplying by 5/4. But we're going to be doing this for each of the next 3 months. So we have to cube this thing. So we'd get 32. When I cube 5, I get 125. When I cube 4, I get 64. 32 divided by 64 is going to be a half. And we'd be left with 62.5 inches. But yeah, your final answer would just be 62.5. So we didn't even have to round it. Someone's asking, can I go back to problem 6? Yes. Was there a question on this one? Yes, go ahead.
So another strategy I found for this problem is that I just multiplied 212 times 212 and then multiplied 211 times 211. And then for 212 to the power of 2, I got 44,944. And then for 211 to the second power, I got 44,521. I subtracted them and I got 423.
Yeah. I mean, you could do this like there's a lot of different ways you could solve these things. That would work. It does require a little bit more calculation though. So it's probably might take a little bit more time to do. But if you can do those powers fast, it is totally doable. And I did have a question. If I buzzed in when I answered, which was like a millisecond after, would they have let me answer or no? So yeah, generally speaking, when you buzz, they're gonna like say your name. Like you'll buzz in and they'll be like, Craig, go ahead, or something like this. So, but if you are answering before, because sometimes it's really tricky. Sometimes you can have two people buzz in essentially at the same time. If anyone's seen game shows where everyone like are hitting things at the same time, it can be a little bit hard, and sometimes it even takes the moderator a moment to realize who actually did buzz in first, depending on the particular setup there. So you want to make sure to not follow the rules so you don't have them disqualify a correct answer or something like that. I mean, a lot of times they're nice about it the first time someone does it, and then they're a lot less nice about it the second time and might not give the person the point. And the worst case scenario is if you say the correct answer, you buzz in, but like the other person buzzes in before you buzz in, and then they call on them and they're like, the answer's 7, and then they get the point, even though that they might not have even solved the problem. They're just using your answer. Okay, let's try another one. Someone's asking, do you need to say all the answers in 3 seconds? They generally give you about 3 seconds, but most of the answers are things that you can say. But if you're in the process of saying the words, they probably, if you're saying 600, 442, and the two part is after 3 seconds, it's probably fine. Okay. So this is the question again with algebra. So if we haven't seen as much algebra stuff, this could be a trickier question for us. We have that 3/4 of the sum x plus 3 is 4 less than twice x. So it's 4 less than 2x. So again, there's a couple ways you could have set this up. You could have had a +4 on the left or a -4 on the right. If you want to solve this, probably the quickest way is to multiply both sides by 4. So if I multiply the right-hand side by 4, I get an 8x minus 16. When I distribute in the 3 into this, I get a 3x plus 9. So then I need to solve for x. So I'm going to subtract the 3x from both sides, leaving me with 5x on the right-hand side. I'm going to add a 16 to both sides, leaving me with a 25 on the left-hand side. And then I'm going to divide both sides by 5, leaving me with x is equal to 5. So I mean, and this is going to be one of those things, like a lot of times on the written contest when you're doing it, they tend to have algebra on the chapter contest more towards the end because they view algebra as a fair game because some schools will offer algebra 1 for 8th graders oftentimes or might have acceleration. So the algebra stuff, high school algebra 1 can be fair game on it, but then in the countdown round, they're just kind of randomly put in. So you might run into one of these problems. So someone asked, why did I have a power 3 here? And this is because on the last problem, this is because we're increasing by 25% for the next 3 months. So we're multiplying by 5/4 3 times because each month you'd be going up by that 25%. Okay, let's try another one. So this is one where if you don't know the formula that you're supposed to use, it's going to be pretty hard to figure out. So we have this rhombus and it has area 84. So there is a formula about rhombuses that the area is equal to the product of the two diagonals lengths divided by 2. And again, this is not a formula that we necessarily always teach in middle school mathematics and not a formula that a lot of teachers expect students to have. So this is one of those, like, if you know the formula, the problem's not too bad. If you don't know the formula, this is going to be a tricky one. So here, what we find is that 84, which is the area, is equal to 14 times, whatever our second diagonal is, divided by 2. 14 over 2 is 7. So then if I want to get D2, it's 84 divided by 7, which is just going to give us 12. Yeah. So, and this is one, I saw a lot of answers where I think people were missing the factor of 2 downstairs. You kind of were multiplying the two diagonals and, so you're doing kind of the right thing, but this is one of those trickier formulas. Like when I was a middle schooler, this was not a formula I had memorized. I can say that. So it's a, high, kind of fancier formula. Okay, let's try another one. So with this one, I might try to break it down by the different kinds of squares that I have. If I'm doing the count, I'm probably not writing this out so much as trying to do this in my head, but maybe I try to do a count of these kind of 4 cases. When I do 1 by 1s, so when I count these 1 by 1s, it appears that I have a total of 12 of them. When I count the 2 by 2s, I have 1 here. When I count the 4 by 4, there's only going to be 1 of those as well, right? The 3 by 3s are kind of the trickier one. But if you look here, the 3 by 3 is going to need to include this middle box and kind of, it could be like something like this. It could be something like this. So you're going to have a total of 4 of those. So if you add up everything in this column, you get a 12, 13, 17, 18. And 18 would be your final answer. So these ones, like, they can be kind of tricky when you do them fast because it's really easy to just miss a little case. This is one of the reasons why, like, I prefer kind of not speed tests as much in contests because but it is, one of these things, if you want to have to make really, really instantaneous, like fast decisions, this is something which tests how you can do that. So with this thing here, one thing to note is that the factorial function grows really fast. So for instance, I could see I might have some of these things memorized. If I was up to 4 factorial, I'm all the way up to 24 already, right? Because the factorial symbol, if you remember from one of our earlier sessions, this is 4 times 3 times 2 times 1. We'd already be at 24. So if I'm using any big numbers here with a factorial, I'm going to get a really big number when I do this sum. So largely it's a question of how can I distribute these 7 things amongst these 3 spots? And so I don't really want to use 4. I don't want to have any of them be 5, 6, or 7. So probably the best thing I could do is maybe have them be 2. 2 is not too bad because 2 factorial is just 2. Maybe I try to use another 2, and if I do that, I use a 3. So this is the only way I can do this without kind of making at least one of them. So if I decrease any of these ones by 1, I'm going to have to increase another one. And so I don't want to use a 4 factorial because I'm already at 24. So this would give me a 2 plus 2, and 3 factorial is just 3 times 2 times 1, which is 6, and would give you the answer 10. So, I mean, in large part, it's just this function grows so fast that you really just want to keep all 3 numbers as small as you can. Alrighty. So someone says, what is a factorial expression? So factorial is what this symbol means. And what it means is that, like, if I have 4 factorial, it means 4 times 3 times 2 times 1. So you're doing a product of all the natural numbers up to that particular point. So like 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And these numbers go ridiculously fast. Alrighty, let's try another. When we do this one thing we can note is all these things have a factor of 1/9. So I have 1/9 times whatever I get when I add the numbers all the way up to 8. Now, this is one of those things that we have a specialized formula for this that we probably have encountered before. This would be 8 times 9 divided by 2. So it's the number that we stopped at times the one larger for the number divided by 2. And then we go to clean this up a little bit. We see that I could cancel a 9 with a 9. And effectively, I have an 8 divided by a 2. And we get the answer 4. Yeah, because it would be actually kind of hard to just add all these fractions. Yes, go ahead.
I did something sort of like that, but I basically paired like the 1/9 and the 8/9 ninths together. So then I would have 9 times 4 over 9. So then I got 4. Or 9 times 4 over 9. So I got 4.
Yeah, so if you did this, you'd have 9 times, you'd get, you would also get 36 if you do this way. Yeah, and so this is like actually how you'd prove the formula. So if you wanted to add up the numbers from 1 through n, you get kind of a nice formula for this. But your approach is actually, one of the ways that you can actually prove this. So if this was x, doesn't matter which way I add things up, I'd find that 2x is going to be, all of these things are just going to be n plus 1. And how many times did I do this? N times. And you'd be able to actually kind of get a formula for this. So your approach is kind of like really the key ingredient to how you can kind of do this stuff. And that's a good strategy. So largely like with these tests, like I'm showing you one way to do things, but there's a lot of ways to do things. You always got to do something you're comfortable with, or that like you can kind of fall back on. That's something that's an approach that you've seen work for problems for you in the past. Yep. Alrighty, let's try another. So with this, we want to kind of come up with a fraction in terms of pi. So I could try to, probably the easiest way to do this is, let's just imagine that this is a 1 by 1 square, because it doesn't give us a length here, because that would kind of fall out of the ratio stuff that we're doing here. So what can we do is we could figure out the area of the shaded region. Well, this is 1/4 of the area in a circle with radius 1. When I think about the area of the entire square, that's just going to be 1 squared. So this cleans up rather nicely because 1 squared is just 1. Dividing by 1 doesn't change anything. Multiplying by 1 doesn't change anything. You just have a pi over 4. I saw a lot of correct answers in the chat. Some people like maybe just had it formatted a little bit wrong or something as well, but that's okay. But this one, if they don't give you dimensions, sometimes you can just pick what are the dimensions that are going to make this problem the easiest to work with. Because this is not per se like a lot harder, but it just is a lot clunkier. If this is an r by r square or something like that, I'm going to at some point have to cancel off the r squared from the upstairs and the downstairs. So if they don't give you numbers, then it pretty much should always work. Okay, let's try another. Okay, so this one is going to require a little bit of algebra. So one of those facts that we had is if we have an average score is 80, so we know that if Charlotte took 7 tests and her average score was 80, this would be what we get if we add up all the values of her tests. And again, she might have done awesome on some tests and really bad on some tests or something like that. But overall, we have 7 tests that averaged 80 points. So we're given that 3 of the tests had an average of 60. So those all together are going to give us 180 points coming from those 3 tests. And then there's 4 other tests that I don't know what the score is, but 4 times what their average is would be the total of the points that I would get when doing that. So I'd have 180 plus 4x. Here when I multiplied, this is 560. So if I subtract 180 from both sides, I would be getting 380. And then I need to divide 380 by 4, which is going to be 95. Now, you might have been able to guess and check or things like this. If you had a calculator, then the guess and check method might actually be faster than doing the algebra. But, with this, you might be able to do some of this stuff in your head. You might really need paper. I tend to like using paper, but you might be not writing out all the details if you're using paper. So you can have kind of some pretty sketchy, rough work when you do these things, as long as you can keep track of things in your head. Let's try another. Okay, so what's going to be halfway between these two things? Well, this is another way of asking for the average of these two numbers. Halfway between them would be what I get when I add them together and divide by 2. Now, I'm probably going to need a little bit of some common denominators here to kind of clean up what I have in the upstairs. So 18 seems to fit the bill. So let's multiply the second fraction by 3 over 3, which would leave me with 15 over 18. So when I clean up the upstairs here, I would get a total of 28 over 18. I'll divide it by 2. And then your work with fractions might be slightly different than the work that I'm doing, so, and that's okay. Maybe I want to cancel some stuff upstairs. Let's swap the 28 over 18 for 14 over 9. It's a little bit nicer. So effectively what I have is I have a 14 divided by 9, but also divided by this number 2. And if I wanted to cancel off my 2 with the upstairs and downstairs, I would be left with 7/9. So I saw some answers were 14 over 18, which numerically is correct. So when they say common fraction, there's some kind of weirder wordings that they sometimes use, like they'll want the lowest form, so kind of canceling things out. Okay. But they'll say 5 seconds or something like this. Yeah. I'm sorry we don't have the full buzzer effect, so we get the scoreboard or something like that, which is annoying. And I've not been reading all these because I feel like for a lot of us, probably looking at it is going to be what's helpful. I think the reading is in large part for the audience because you might have parents and teachers watching this round. So depending on the particular contest, at the regionals, at the chapters, sometimes they allow parents to be in the room, but it's not all that exciting to watch your kid write on paper. But the countdown rounds are more of an event, and so they sometimes have spectators or people from the local newspaper or something occasionally, maybe at the state one. So if I'm faced with this problem, it might be difficult to guess and check. So what I probably want to do is, there are fancier ways that we might be able to do this, but one thing I can see is 16 is really a power of 2. So this would be the same thing as 2 to the 4. That gives me 16. This with an x plus 3 is equal to 2 to the 5x. And this is going to tell me that these two exponents need to line up. So 4x plus 12 needs to line up with 5x. Let's subtract 4x from both sides. If I do that, I'm left with x is equal to 12. So someone said you should read out loud to distract us like in the real competition. I will do that. I do take requests, right? So okay, I'll do that. Yeah. So it can be a thing, but like zoning out probably helps you because like if you're just kind of waiting for the person to finish. And I've seen also competitors try to be polite and wait until the person finishes reading first. And when they have the answer, don't do that because if you have the answer, like the other person can ring in the meantime, so one of those times politeness is maybe not the way to go. What is the value of 1 plus 2 minus 4 plus 8 plus 16 minus 32? With that one, y'all were answering it so fast I could not keep up with the emojis, so I apologize. But this one, there are some like high level tools you could use, but it's probably more direct as to kind of group up some terms. So if I do these things, put them together, I got a 3 minus 4, which is those things turn into a -1. If I kind of take these things, I got a 24 minus 32. Those things go to -8, and I would get -9. So you could use potentially some fancier tricks here, but I don't know. This is probably just one that you just kind of compute, but grouping is probably a good strategy on this. Okay, so let's try another one. A person who has A quarters and B nickels has $5.60 more than a person who has A nickels and B quarters. What is the value of A minus B? I can give you another 15 seconds on this one. This one takes a little bit longer than the last one to do, if I'm honest. So it's not always consistent that the higher number questions take longer or harder. Sometimes it's all over the map. All right. So again, for those of us who maybe haven't had much algebra, this is a problem that you might not even know how to start, and that's okay. You might be able to guess and check. You might be able to do things like that. But so if a person has A quarters and B nickels, so let's just do this all in terms of cents. So if I have A quarters, that's worth 25 A cents. If I have B nickels, that's worth 5 B cents. This would be worth, okay, so that person has $5.60 more. So if I'm converting to cents, I have 560. If you want to keep things with decimals floating around, that's okay. But the second person has A nickels. So we have 5A and they have B quarters. So 25B. So this person's amount plus 560 cents is equal to the first person's amount. So what we do is we subtract this 5A and this 25B from both sides. If I do that, when I take away 5A, I get 20A. When I take away 25B from 5B, I get minus 20B. Now, this might seem that I'm not in a good position to answer this question, but note here, they actually are asking about A minus B, and I have kind of an A minus B lurking on this left-hand side because what I have on the left-hand side is 20 A minus B. And then with a little bit of division, you get 560 over 20. And you get 28. And again, there's multiple ways that you can solve some of these problems. So if you did something different and got the correct answer, you guessed and checked, whatever, that's A-okay. There's a lot of routes. Math, as I always say, is a choose your own adventure novel, like where I want to do this, I go to page 37. I want to do that, I go to page 72 in the book. I mean, I don't know. So these things, pre-tablets used to be all the cool thing, but now tablets, you could just press the button and it'll take you to the page. Okay, let's try another one. I'm supposed to read these. For how many positive integers m does the line given by y is equal to mx intersect the segment with endpoints 2017 and 1720? They like to use the year. So this is one that kind of does basically assume that you have been kind of doing some acceleration and you've seen some algebra because it's hard to do without any algebra. If we're just trying to plot these points, so we got the point, 2017, and we got the point 1720. So we're thinking about the line segment between these things, but you could also think about what are the slopes? If I'm just thinking about not requiring that things be an integer, what is the slope of this thing? The slope, the rise over run, is going to be 20 over 17. And this is a number which is less than 2, but it is strictly bigger than 1. Because I'm really caring about what slopes I could have that happen to be integers. I could do something similar with doing a slope to the other point. If you're looking here, what is your slope going to be? Your rise is going to be 17 over your run, which is 20. This is a number clearly bigger than 0, but it's strictly smaller than 1. So when I think about all the lines that could go between these things, right, that look like y is equal to mx plus b, I have all these different slope possibilities, between 17 over 20 and 20 over 17, but there's only going to be one of those that happens to be an integer, and namely that's going to be the line y is equal to 1x. So our answer here, there is only one integer m, which is going to work for this. So this was a sneakier one, and again, this is really kind of assuming probably that you're an 8th grader taking accelerated like high school algebra 1 or something like this. Someone said, I thought it was a trick question. Maybe, but this also, like, sometimes if you don't really know an answer, this is where 1, 0, like 2, I mean, like 0, 1, and 2 are very reasonable answers for a question like this if you're just kind of guessing. Yes. All right. If you want to do another one, get through question 20. I realize I'm 3 minutes over, so let's do one more, and then maybe we can call it. An earthquake that measures x plus 1 on the Richter scale is 10 times as strong as an earthquake that measures x on the same scale for any positive number x. How many times stronger is an earthquake that measures 6.9 than one measuring 4.9 on the Richter scale? Yeah, so the Richter scale is kind of a weird scale where every time you jump up the number by 1, it increases by a factor of 10. So we do actually have a fair number of earthquakes here in Kansas, but the Richter scale stuff is probably more of a prevalent thing for those of us who've lived in California or some other places that are more affected. I've only had one earthquake in Kansas that I really, really noticed, whereas when I lived in California, I'd notice these things. So when we look at the difference between these two numbers, we have a 6.9 on the Richter scale and a 4.9 on the Richter scale. So the difference between these two numbers is 2. So going from 4.9 to 5.9 is an increase of a 10 factor. And going from 5.9 to 6.9 is another increase by a factor of 10. So what we have here is a 10 times 10, or a 10 squared. The earthquake that is 6.9 on the Richter scale is 100 times worse than an earthquake measuring 4.9 on the Richter scale. Yeah. So this is probably a good spot to stop. I mean, but like, so for these tests, they're going to have things prepared. They have about 120 of these questions prepared. So your parents or guardians do have information where they can find these things. If you're ever having a hard time finding resources, just let me know. I actually have on my computer a lot of different old MathCounts and AMC8s, but you'll be able to find a lot of problems and a lot of solutions if you go online. I hope you all have a wonderful afternoon. I'll stick around just in case anyone has any questions, but have a great day. Enjoy the weather. Assuming it's nice where you are. So I guess Manhattan's pretty nice today.
Thank you.
You're welcome. Anyone have any questions? Not hearing any questions, so I'm probably going to close up the session. But if anyone, can raise your hand, use emoji, toss stuff in the chat, or turn your mic on if you did have questions. Maybe not. Well, okay. I hope you all have a wonderful day. Enjoy the nice weather outside if you're in Kansas.